Hello. Am I audible?
Yes, sir.
Yes, sir.
Oh, okay, fine. Thanks. Okay, do you have any doubt from week 7 which you want me to discuss? Okay, so have you started week 7 or like you're still with week 6?
Started, sir.
Started like, so are you facing any problem with week 7 till now? Okay, so then, yeah. So let me solve maybe few questions from week 7. Yeah, so more or less, I'm planning to solve few activity questions. Okay. So you can see my screen, right?
Yes, sir.
Oh, yeah, thanks. Okay, probably I'll come to this sequence part. Let me discuss few sequence part, and before going into the sequence, let me solve this particular questions related to these functions. Okay, so since you know this question very well, like how to check whether a function is injective like or surjective. Okay, that is basically it's a concept which is a combination of week 1 and probably week 5 or 6. Okay, so as you can see, so this is more or less is asking which of the following functions are injective, right? Or maybe surjective. Okay. So what is your function over here? So your function is basically what? Your function is f of x plus 1 by x, right? And for the option number 1, so you need to consider this function. Okay, for option number 1, you need to consider this function from the set of all real number minus 0 to r, right? So if you have such function, the question is whether this function is injective or not. Any idea how we should start solving this option? Whether this function is injective in when my domain is r minus 0. Any idea how we should solve this question? See, as you can see this, so okay, so this expression is sort of symmetry, right? X plus 1 by x. So you have x here plus 1 by x, right? So as you can see, if I take x to be half, x to be 2, then what is my f of 2? It's basically 2 plus 1 by 2, right? And similarly, if I take x to be 1 by 2, right? If I take x to be 1 by 2, then my f of 1 by 2 is basically what? It's 1 by 2 plus 1 upon 1 by 2, right? And this is nothing but half plus 2, right? So as you can see, so when I'm taking x equal to 2, I'm getting 2 plus 1 by 2, and when I'm taking x equal to half, I'm getting 2 plus 1 by 2 as well, right? So in some sense, my x, so in some sense 2 is basically not equal to 1 by 2, but the images of both the elements are same, right? So this information is sufficient for me to tell that my function f is what? Function f is not injective, right? Because I have two different inputs in my domains, right? 2 and 1 by 2, they are basically inside r minus 0, but their images are same, right? So I have two elements in my domain, distinct element in my domain, but their images are same. So that is enough for me to tell that this function f is not injective when I am considering from the set of non-zero real numbers to R. Okay, so this option 1 is basically incorrect. Okay, so this is not it's not an injective function. Okay, so the next option says, okay, so the next option says f is an injective function if the domain of f is n. Okay, so next thing is, instead of considering from this function f of x from r minus 0 to r, I am considering this as a function from set of all natural number to r. Okay. So the question is, I just need to check when I am considering this function from the set of all natural number to r, okay, whether this function is injective. Okay. That is my question. So I just need to know whether with this domain, in this domain, whether this function is injective or not. Okay. That is what I want to say. So, okay, so the thing is, one thing you can see, so basically what you can see, that if I have two natural number, okay, suppose let x and y. So okay, one major thing you need to always you need to remember that uh, in week 7, 8, 9, okay, so here your natural number is basically starts with 1, okay, instead of 0, because in previous week you know that 0 is always inside natural number, but for this calculus part, you always have to remember that your natural number actually starts with 1, 2, and so on. Okay, so for the calculus part, 0 is not a part of n. Okay, so since 0 is not a part of n, that's why, as you can see, this function is a well-defined function. Since 0 is not a part of n, that's why this function is a well-defined function. Because if 0 is if 0 is a part of n, then basically I can't find the value of this function at x equal to 0, because f of 0 is what? 0 plus 1 by 0, and this 1 by 0 has no meaning, it's undefined. Okay, so that's why if 0 will be a member of n, then basically this function is not defined. Okay, so that's why, as let me tell you again, 0 is not a part of natural number. Okay, so that's why this function is well defined. Like I can take the inverse of a natural number, non-zero number. Okay, and since 0 is not the part of n, so that's why this is a well-defined function. Okay, so let's come back to the question. So what we want to do, we want to check whether this function is injective or not. So suppose I have two numbers. Okay, suppose I have two numbers. Let's say let x comma y in my set of natural number. So and x is not equal to y, right? So if I'm taking two distinct number, that means either x is greater than 0 or y is greater than, sorry, if I have two distinct number x and y, then I have two possibility, right? Either x is greater than y or y is greater than x, okay, right? So either x is greater than y or y is greater than x. Okay, so without loss of generality, what I'm going to take, I'm going to simply take that. Suppose x is greater than 1. Okay. So suppose x is greater than y. So that means, so one thing I can tell that, okay, if x is certainly greater than y, then x plus 1 by x is also greater than y plus 1 by 1, because I have two natural number. Okay, suppose I have suppose my x is 1, and no, x is 2 and y is 1. Then it's clear, right? 2 plus 1 by 2. So here x is greater than y. So you can see x plus 1 by x is always greater than y, which is 1 plus 1 by 1. And this is 2, and certainly this is greater than 2. And similarly, if you have 4 and 3, okay, suppose your x is 4 and y equal to 3, then 4 plus 1 by 4 is always greater than 3 plus 1 by 3. So if x is greater than y, okay, then x plus 1 by x is greater than y plus 1 by y. So that means f of x is greater than f of y, right? So if x is greater than, just a minute. So basically what basically we prove? So we basically prove, so in particularly we basically prove that if x is not equal to y, that means f of x is basically not equal to f of y, right? So in other words, my function f is injective. Okay, so what basically we prove? If x is not equal to y, then f of x is basically not equal to f of y. Okay, so that means two distinct inputs will always have distinct output. Okay, so that means my function is injective. Okay, so this basically proves that option 2 is correct. Okay, so this basically proves.
Since it is
Hmm.
increasing function, it will be 1 1.
Increasing in the sense, yeah, correct. So that is basically we proved that this function is increasing. Okay,
Yes.
so this basically we proved that this function is this. If x is greater than y, basically we prove that f of x is greater than f of y. So that means this function is also increasing. Yeah.
Yes.
Correct. Okay, so yeah, so the next option is, let's say, the option number 3. So here we just need to consider the function from q minus 0 to r. Okay, so set up a rational number minus 0 to r. Okay, so my function is what? X goes to x plus 1 by x. So the same question is basically we need to check. We need to check whether this function is injective or not. So any idea how we should proceed?
You can take the value x is equal to 2 and x is equal to 1 by 2.
Correct. So whatever argument we gave here for r, okay, so whatever argument we gave in case of r to show that this function is not injective, I can give the same argument, right? So at x equal to r and 2, the image of the function at these two elements are precisely same. So half is same as f of 2, and certainly half and 2, they are rational numbers, non-zero rational. So this argument makes sense. So that means f is not injective. Okay, so option 3 is incorrect, and f of next is basically, instead of taking so we are taking from z minus 0 to r. So this is basically all non-zero integers. Okay. So what about this one? Whether this function is injective or not. So basically we have discussed a similar kind of thing, right? Like, so we have discussed similar kind of things for natural numbers. Okay. So any idea how we should do it for non-zero integers? Okay, so basically the same argument will work. Okay, so I'll suggest you check the same argument will work. Whatever argument I gave you for this one, the natural numbers, you can apply the same argument over here to tell that f is.
But technically, we can use any two natural numbers, no, sir.
Sorry.
We can use any two natural numbers. Still, it has to work.
No, certainly I have proved it for natural numbers, right?
Yeah.
So now instead of dealing with natural numbers, you have to use with any two integers.
That's all.
Non-zero.
Any two integers we can use. There is no.
Yeah. Same thing you can basically use. The proof basically works same to same without any changes. Okay,
Yeah.
so
Sir,
yeah.
we will deal with this question in two cases, whether it is a positive integer or whether it is a negative integer. As in one case, it might be increasing, and in the other case, it might be a decreasing function.
Yeah. In some no, I guess it's an increasing function. Okay, so for example, if you see, let's say even for negative also, right? If you see actually, you take let's say x equal to -2, okay, and y equal to let's say -3, right? So as you can see, x is greater than y, right?
Yes, sir.
So then what is f of x? F of x is basically what? -2 -1/2, right? And what is f of y? It's basically -3 -1/3. Okay, and as you can see, this thing is greater than this one. So again, it is so this, even if you consider this function from z minus 0 to r, still it is increasing throughout z minus 0. Okay, you actually you don't have to consider it separately. Okay, as I said, the same proof will work throughout. So instead of considering x and y to be natural numbers, okay, you just take them as this. Then actually you can write this same thing. You can write the same thing. All these things hold even if x and y are non-zero integers. Okay, so let's go to option 5. So it's saying basically f is a surjective function if the domain of f is n and the codomain of f is q. Okay, so now suppose this function I am considering from n to q, right? N to q, and this map is what? X goes to x plus 1 by x. The question is whether this function is surjective or not. Any idea how to check how to, if this function is surjective, how to prove it, and if this function is not surjective, then how we should disprove it?
Yes. Can we do it like if we equate it with 2, which is a rational number, and try to evaluate that exists no value of x for which this function is equal to 2, and we may give the argument that since it is a rational number and it does not belong to the range of the function, which is the codomain, so it is
Correct.
not a surjective function.
Correct. But whatever example you gave, 2, right? So if I take x to be 1, right?
Means my example was wrong, but
Yeah.
I think the argument
Certainly that is basically we are saying, yeah, so see, this function is certainly not surjective, but I want like for which element in your codomain, okay, for which element in your codomain, this particular element has no pre-image in the domain. Okay, so this basically you need to find an element in the codomain which has no image pre-image in the domain. So that is enough to tell you that this function is not surjective. So okay, so let's start with some easiest element. Let's say 0, right? So you take 0 in your codomain, right? So my question is whether 0 has any pre-image in the domain. Whether 0 has any pre-image in the domain. So in other words,
Plus addition, you will not be able to get 0.
correct. That is what. Yeah. So you can't if you take any natural number. Okay. If you take any natural number, so as I said, natural number starts with 1. Okay. So if you take any natural number, so then f of x, which is basically x plus 1 by x, right? This will be always greater
Than 0.
greater than, yeah. So instead of greater than 0, I can say something more. It's always greater than 1, right?
Okay.
Because certainly x is a natural number here and x is greater than equal to 1. That means x plus 1 by x will be strictly greater than 1. So f of x can't be 0. So f of x can't be 0 for all x in A, right? So f of x can't be 0 for all x in A. So that means f of x is so that means f is not surjective. Okay, and yeah, so this function is not surjective. So the question number 6 says, okay, I just need to change the domain. Okay, I just need to change the domain. So instead of considering this function from in my n to q, I just need to consider it from z minus 0 to, and I basically the question is same. Okay, I'm just changing the domain and I'm asking the same question whether this function is surjective or not. Whether this function is surjective or not. Again, what? So what is the answer? So basically, I'm asking the same question. Like instead of taking this domain to be natural number, I'm just taking the domain to be set of all non-zero integers. So how I should proceed? I already gave like some answer over here. So can we apply the same thing over here? So in other words, what actually I want to ask whether 0 is 0, whether this 0. So 0 is basically in my codomain. Whether
No,
0,
sir.
so 0 don't have any pre-image, right?
No, sir.
Yeah.
I mean, for any input for this function, let's take -1 or -2, even
Hmm.
1 or 2. For minus, it's adding, and for plus, it's also adding. I mean, it's x plus 1 by x or 1 by x plus x. So for any arbitrary value, let's say -1. So it's like 1 by -1 means -1, and again -1. So it's giving us -2. So
Correct.
we are not getting any pre-image for 0,
Correct.
the domain.
Yes. Yes. So yeah. So basically, what basically he's saying that if x is less than 0, that means f of x is always less than 0.
Yes, sir. Yes, sir. So that's the mathematical expression. Yeah.
Yeah.
Yeah. Yeah.
So and similarly, if x is greater than 0, then f of
F
x
of
is
x is also greater than 0.
greater than 0. So in both the cases, so I'm always getting a number which is not equal to 0. Okay, so that means this function is not surjective. This is not a surjective function because certainly I'm not going to get any pre-image for 0. Okay, so there is no element over here that maps to 0. Okay, so is there any doubt in this question? Okay, so before moving into sequence, I just want to know, is there any doubt from other part, like before sequence, you have any doubt? So yeah, so basically,
Can you just show, sir, the fourth option that you solved, sir? Yeah, the fourth option that you solved over there. Can you show that, please, sir?
so
Once.
basically, I didn't solve option 4. Okay, basically, if you see, basically I said the same argument, like I gave some argument for option 2, right? So I gave some argument for option 2. Okay, the same procedure you can apply to option 4 as well.
Okay.
So the method that is basically for option 2 and option 4, they are same.
Okay, sir. Okay.
Yeah.
Sir, activity 7.1 and question number 10.
So the first activity. You mean this question, right?
Yes, sir.
Yeah. So what is your doubt over here?
So, 1 minute. Sir, the function g of x is equal to 1 upon 1 plus e to the power x gives bisection from R to 0, 1, sir. Here, sir, I didn't get it how this option is right or wrong. So I have got only 2 options correct, but there is 3 options. So
Yeah.
that's
So which options you are getting? So this is, what about option 1?
1-to-1 function from R to M is yes, sir, it is right, sir.
Because m is, so the main thing is m is a, so here the important thing is m is a non-zero integer, right?
Yes, sir.
So this option is correct.
Yes, sir.
And second option is certainly incorrect, right?
Yes, sir.
Uh,
Sir, but it is onto function, sir. It is right, sir. According to my point, it is right. I think it might be right. Second option.
Why?
Sir, it is x is
This is
Quadratic is an onto function.
quadratic is a onto function. Why? What about?
So quadratic is onto function only for the positives.
This is a quadratic function, right?
Okay.
yes, sir.
Is it onto?
No, sir. It's not.
This is not onto, right?
It's
not
not
on.
onto, sir.
It's always positive, right?
Yes, sir. So for any positive value, we are getting this.
Hmm.
Even if we take the back method, which is like x square equals to any arbitrary value y for non-zero, and we take the if we use the pre-image method, we will get the pre-image for plus of root y, but not of minus of root y.
Correct, correct. So certainly you can't have any number in the domain that maps to -1. Okay, you can't get any x such that x square is -1, right? So that means -1 don't have any premise, right? -1, so you can't get any x that maps to -1, right? So because square of a real number certainly can't be negative. Okay, so this
Yes, sir.
function is not surjective, right?
Okay.
Okay, so the thing is, in fact, in any quadratic function can't be surjective. Okay, in some sense, because if you draw the quadratic function, okay, if you draw a quadratic function, so what will be the, like, it will be either, suppose this is upward, right? So then basically you are missing lot of points. Okay, so below, so if you take any number on the y-axis which is below this
Okay.
red line, then that number is not in the
Yes.
range of this quadratic function, right?
Okay. Okay.
And similarly, yeah. So similarly, if my so instead of this is open upward, if it is open downward, okay. So suppose my function is open downward. So instead of taking like this, if I take any number
Above.
yeah. So above this, so if I take any number y above this point, okay, above this point, any number here or here or here, then this has no preimage in my domain. Okay. So in fact, any quadratic function, like if I take,
Yes, sir.
yeah, it's not on.
Sir, but it is not
Sir,
onto from R to R. And sir, where it can be onto, sir, in the what range, sorry, in the what domain it can be onto, sir, please?
In what domain you are saying?
Yes.
So you are taking the maximum possible domain R, right?
Okay.
You can't go beyond R, right? Because certainly we are not dealing with complex number. Okay. So you can't, certainly you can't increase your domain. The only thing what you can do, you can reduce your domain, right?
Yes, sir.
Sorry,
Yes, sir.
you can read. You can read. So if you reduce your domain, then it is not going to help you, right? So instead of that, what you need to do, you need to reduce your codomain, right? So what you can do, you can, instead of taking the codomain to be whole R, okay, you can take the codomain to be the just the range of that function, right?
Okay. Yes, sir.
So if you take the codomain, so here, for example, so for here, let's say this example, right? R from R to R, f of x is equal to x square. Okay. So as you can see, if I reduce my domain, right, then it's not going to help me, right?
Yes, sir.
Certainly, if I reduce my domain, then certainly I'm not going to get negative real number. Okay. So reducing domain certainly is not going to help me. Okay. The only thing what I can do, I need to reduce the codomain. Okay. So to make this, yeah, correct. To make this function surjective, what I have to do, instead of taking whole R, I have to basically take the range of this function. The range of this function. Correct. So instead of taking R, if I take this function to be R2 positive real number. R2 setable, not positive, it's actually setable all non-negative real numbers because I am considering 0 as well. Okay. So R setable real number which are greater than or equal to 0. So in this case, this function is surjective. Okay, because basically I can get all non-zero real numbers as my image.
Yes.
So instead of reducing your domain, you should reduce your codomain, okay, to make the function to be surjective. So for example, in this case, for example, this let's say this example, let's say. So instead of reducing your domain, you just need to reduce your codomain. Yes, yeah, codomain. So here what you need to take, instead of taking whole R, you need to take all the points which are above this point. So this is, let's say, y is equal to some, let's say, alpha. Okay, you need to take all the points which are above alpha.
Yes, sir.
Okay, in that case, so if you consider this function from R to
R greater than or equal to alpha
alpha comma infinity,
infinity.
right? So in this case, this function is surjective, okay, because my codomain and range, they are precisely same.
Yes, sir.
And similarly for here, if suppose this thing is, let's say, beta, okay, if I consider this one from R to
Beta to minus infinity.
yes, minus infinity to beta.
Yes.
So okay, beta should be closed interval. So in this case, this function is surjective. So what I am doing, so instead of reducing my domain, I am basically reducing my codomain. So in that case, I can make this function to be surjective. Okay. So now is it clear why this option is incorrect?
Yes, sir. Got it.
So what about option 3?
It is true, sir. It is unbounded function.
Yeah, so it's sort of easy to see, like if you take x to be negative numbers, right? So if I take x to be minus 3, then it's basically e power 3, right? 1 by,
Yes, sir. E to the power 1 by e to the power minus 3, which is e to the power 3.
yes. So again, like if I take x to be some large in some sense, in the sense of magnitude, okay, large negative numbers like minus, okay, let me emphasize that in terms of magnitude. Okay, so minus 10, then I'll get some even larger number. So if basically what, in other words, if x will go towards minus infinity, then my function f of x
E to power infinity.
e power x will go towards plus infinity.
E to power infinity. Yes.
Yeah, correct. So so in some sense, e power infinity will go towards infinity.
Yes.
Right? Yeah. So that means this function is certainly not bounded.
Sir, can we draw the graph of these functions?
Yeah, certainly we can. It's more or less just drawing the graph of this function is not difficult. Okay, so what is my function?
So f of x equals to 1 by 1 plus e to the
Yes.
power x.
So this is nothing but e power minus x, right? That's all. Okay. So it will have some some same kind of figure, but in some sense it will be reversed. So you'll get basically the same thing. Okay, so in slightly reversed manner. It will go like this. Okay, so if you see your the graph of Ex, right? So the graph of Ex is like this, right? This is the graph
Yes,
of
sir.
Ex. Right?
Yes.
So as you can see, whatever is happening here, okay, for positive x, okay, for positive x, whatever is happening here, the same thing happening here for negative x, right?
Yes, sir.
That is the only difference. Okay, because
And sir,
Hmm.
e to the power minus x graph also similar to the exponential graph of a is greater greater than 0 but less than 1, sir. Same graph it is.
correct. Yeah. So because here actually what is a here? So I can write this as 1 by e power x, right? I can write. So what is a here? So a is basically what? 1 by e, which is greater than less than 1 and greater than 0.
Yes, sir.
So yeah, so it's more or less this graph a power x where a is less than 1 and certainly greater than 0. So yeah, so in some sense it's basically some kind of yeah, whatever is happening here for positive x is happening for negative x, and whatever is happening from negative x, and it's happening for positive x.
Yes, sir. Thank you, sir.
Yeah. So okay, so I guess the main question was something else. Like you asked that question. Okay, let me. I guess I have.
Third option, sir. Fourth option.
Yeah. So let me check what is that option.
So that option is g of x equals to 1 by 1 plus e to the power x gives a
Okay.
bijection from r to 0, 1.
Just a minute. F of x equal to
1 by
hmm.
1 plus e to the power x
Okay.
gives the
So
bijection from r to 0, 1.
okay. So we are considering this function from r to 0, 1, right?
Yes, sir. We need to prove the bijection in
Yeah.
this
So
mapping.
okay. So before going into bijection, my first question is whether this function is well defined. So what I mean by this thing?
Yes, sir. Yes, this
What
function.
I mean, yeah. So what I mean by this thing, that whether this if I take some real number, okay, whether my f of x will land inside 0, 1. Because if I take some x and my f of x is 5, then basically I am out of this interval, right? So in that case, my function is not well defined, right? So if my function for some values of x, if I land in 5 or maybe 10 or maybe -1, then certainly I'm actually not in that interval. My image of the function is not in that interval. So in that case, certainly I can't say that this function is well defined. So first let's talk about whether this function is well defined or not. Whether if I take some value of x, whether I'm basically going inside this or not.
Sir, yes, sir, it is well defined, sir.
Yeah. So how can you tell me how?
Sir, if I take any value for x, it is landing between 0 to 1, sir. If I
Yes.
take suppose that e to the power 10, then it gives value between 0 to 1.
Yeah, correct. But okay, so what I want to know, like, is there any mathematical proof for that we can give? So certainly, if I take numbers one by one, then certainly I can tell. Okay, but certainly I can't do for all real number. Okay, so for that I have to give some general proof. Any idea? Anyone wants to say?
The third statement, 1 by e power x, we can see that it is okay.
No, it's a unbounded function. Certainly, yeah, it's basically the range is basically 0 to infinity. Okay. So if you see e power minus x here, so this is basically
Here, y coordinate, y intercept is always 1.
And y-intercept is 1, and as well as this, if you see this
It is
function is
coming below 0. I mean, below 1. It is towards 0. It is going. 0 is
but
the
yeah, but in this side it's actually going towards 0, right?
yes, sir.
But in negative side it's going towards infinity, right? So this certainly, if I consider this function, then this function, let's say this function r minus 0 to 1, x goes to e power minus x, then certainly this is not well defined. Because my f of 0 is itself 1, right? Which
Yes,
is
sir.
not in my
Range.
not range, actually it's codomain. Yeah.
Codomain.
So yeah, so then this function is not well defined. But what about this one?
So plus 1 is there now, sir.
Hmm.
Denominator there is plus 1.
Yeah, probably you can now you can avoid 0. What about all the negative real numbers? Because if you see here, like you take the minus infinity, sorry, minus 10, x is minus 10, then basically I'm getting e power 10, which is way more than this 1. So okay, so let me prove this. So so one thing you know, that e power x is always greater than 0, right? This is true for all x in R. So that means 1 plus e power x is greater than 1. Right?
Yes, sir, true.
Now you take the reciprocal.
Oh, less than 1.
Yeah.
Oh, so you use this property.
Right? And also, like this thing is greater than 0 as well, because 1 plus e power x is greater than 0, because e power x is greater than 0, so 1 plus e power x is greater than 0. So if a number is greater than 0, then its reciprocal is also greater than 0. So whatever my x is, 1 by 1 plus e power x is always inside this interval.
Yes, sir.
So that means this function, whatever my function, this is a well-defined function. Okay, so the next thing is what probably we need to check. This function is bijective, right? Yeah. So what I have to check for bijection, I have first check this function is injective, right? So let me try. Suppose f of x equal to f of y, right? Suppose, so I want to check injectiveness, whether this function is injective. So suppose f of x equal to f of y. So in that case, what I will have? Right? This is what I get, right? By this. So now you reverse both the things. So basically what I want to say, if 1 by a is basically 1 by b, then a is equals to b, right?
Yes, sir. Like taking the reciprocals on the both sides. It
Correct.
will be equal.
So then what from here, what I will get? 1 plus e power 1 plus e power x is basically 1 plus e power y, right? So from here I will get e power x equal to e power y, right?
Yes, sir.
So
Yes.
now what I can conclude from the last equality?
X equal to y.
X equal to y, sir.
X equal to y.
So my function is injective. So basically assumed f of x equal to y and I'm getting x equal to y. So this function is injective.
Injective.
So the injective part is done. So f is injective. Now I need to show that this function is surjective. So for the surjectiveness, what I need to show for each y, over here, right? I should have a x so that f takes this x to that y. So that is the whole idea of surjectiveness.
Injective.
No, surjective.
Subjective. Sorry, sir.
Yeah. So let y is my here. And what I want to do, I want to find a
Pre-image, no, sir.
x in R such that f of x is y, right? That is my whole point. So once I show this, then I'm done. My function is surjective. So what is f of x? F of x is 1 plus e power x, right? Y, right? So if I cross multiply, then what I will get?
Y plus e to the power x into y equals to 1.
Correct. Equal to 1, right?
Yes, sir.
So y, try to remember, y is basically in this region, 0, 1, right? In this interval. One minus y, right? So if y is this region, then 1 minus y is positive, right?
Yes, sir.
Yes, sir.
Then 1 minus y by y is also positive.
Yes, sir.
So now I can take the log, right? Because I know that this number is positive, 1 minus y by y. Okay, this number is,
Yes, sir.
this number is positive. That's why I can take the log. Okay, so that's why this whole thing makes sense. Okay. So basically what I proved, for each y in my range, sorry, not range, each y in my codomain, if I pick any y in my codomain, this is precisely the pre-image of that y, right? So for example, if I take y equal to half, in my codomain, so the pre-image of half is basically ln 1 minus half by half, which is 0. Okay. So 0 maps to half. Okay. And there is nothing special about half. You can instead of in half, you can take any
Half
number.
is 1.
Sorry.
0. Log of 1 is 0.
Log of 1.
Okay,
That
yeah,
is 0.
0. This is log of, this is 1, right?
Yes, sir. Yes, sir.
Yeah,
Half by half, so 1. So ln 1 is 0.
So yeah, so basically 0 maps to half, right? So the pre-image of half is 0. So as I said, there is nothing special about half. You can try with 1 by 3. You can try with 1 by 5, and you just need to substitute 1 by 3 over here to get the pre-image of 1 by 3. You need to substitute y equal to 1 by 5 to get the pre-image of 1 by 5. Okay. So it's clear right now why this function is surjective.
Yes, sir. Clear.
Yes, sir.
Right. Okay. Okay. So is there any other doubt from 1.2? Sorry, not 1.2, 7.1, 7.2, 7.3. Okay, so let me discuss few things from sequences. Yeah. Okay, so I guess you have watched the lecture of this sequence and what is limit of sequence. So let me briefly discuss few things. Okay, so can one of you tell me what is sequence? So if you have watched the lecture, can one of you tell me what is sequence? So if you see your first activity question of maybe 7.4, the question number 1 is all about this thing. Okay.
For every a of n, a of n plus 1 is greater than a of n.
No,
And
that is probably you are okay. I'm not sure
limit. Okay.
No, I'm not asking about limit. I'm not asking about. No, I'm not asking about limit of sequence. I'm not asking about increasing sequence or decreasing. My first question is what is sequence?
An ordered set.
So this is also a ordered set, right? So let's say I take, for example, this one, 1, 2.
Every element flowing a different definite pattern.
Definite.
Sure.
Okay, so yeah, so like yes, Certainly, yeah, this is not the correct way of saying what is sequence. So basically, okay, so forget about now sequence, what is sequence? I'll come to that, the proper definition. But so in generally, if you see, basically sequence is basically it's a bunch of numbers with the indices coming from the naturals, right? Correct or not?
Yes, sir.
So that means what basically I have A1, I have A2, I have A3, I have A4, and so on. So what is that? So basically, as you can see, so for 1, so when I'm saying basically 1, then I'm getting this A1, right? So this 1 is just appearing in A1. So this 2 is appearing in A2. So for each, so in some sense, for each natural number n, okay, so each natural number n, I am getting some real number a, right? So then basically what I am getting, so in some sense I am getting a function, right? I am getting a function. So when I'm saying I have a sequence, so this sequence is basically it is giving me a function from the set of all natural number
Into R, sir.
well R. So for example, for 1, I am getting A1, right? For 2, I am getting A2, and so on, right? So once I have a sequence, so basically what I have done here, I have started with a sequence, right? This is my sequence, right? And I have constructed a function, right? I have constructed a function from the set of all natural number to the set of all real numbers. Okay. And I can do the complete opposite thing. Okay, so let me start with a function. Let me start with a function. So my function is what? Natural number to R. Now, using this function, I can construct a sequence. Now, suppose I have a function from the set of one natural number to R, and what I want to do, I want to construct a sequence. I want to construct a sequence using this set. So how I should do it? How I can construct a sequence from this function? Any
Sir,
idea?
so it will be the
For
same
every
thing, no,
X, you
sir.
put one natural number, sir.
So for I mean, sir, indexes are the same. I mean, for 1, we are gonna get A1. So A1 could be any arbitrary real number. I mean, real value.
No, that's no, certainly arbitrary, but so I can like my so you are not, so what I want to do, I want to construct a sequence out of this function.
No, we have to
So, sir, you're
for
trying to
f
say
of X, you
from
put f of A, so A of n. So, for
Correct,
example,
correct. So you are basically saying my an should be f of n, right?
f of n. Yes, sir.
Correct. That is the precise answer I wanted to know. Okay, so basically I can construct a sequence, and what will be my sequence? My A1 is F1, my A2 is F2, my A3 is F3, and so on. So
So, sir, you were asking about the function definition for this, no?
no. I'm
I
asking.
mean,
I was
yes.
asking.
I mean, sir, for any, let's say for f of n, so you are trying to say like for 1, 2, 3, what we are gonna get. So that's a function like
No, no, no. So-
expression. Like for f of 1, we are getting a1, and f of 2 is a2. So
No,
it's-
I'm constructing a sequence. So what is the first term of this sequence? Basically f of 1.
got it.
And second term is basically f of 2. And the third term, so as I said, so here actually what? Here I have started with a sequence, right? This is
Yes.
a sequence. And I have constructed a function from the set of all natural number to R, right? So here I am doing the complete opposite thing, right? I have a function, okay? I have a function.
And we are creating a sequence out of it. Got it, sir. Got it.
So as so basically what so our starting question was what is sequence. So sequence is, as you can see, once you have a sequence, you have a function, and you have a function, you have a sequence. Okay, so mathematically what you can see, sequence is nothing but it's a function from the set of all natural number to R. Okay, sequence. So basically the answer what I was expecting, the sequence is basically is a function from the set of all natural number to R. Okay. So now once you know this, actually you can now solve the activity question 1. Okay. So now if you go back to this question, right? Now if you go back to this question, now I guess you'll able to solve this question. Okay. So which of the following, so these are bunch of functions, okay? So which of the following function will represent a sequence? Any idea? What will be the what are the correct answers?
So F2 and F5.
F2 would be
Second and
one,
fifth.
Sir, F2, F5.
and the F5 would be another one.
F5.
F5. Yeah, correct. So yeah, so as you can see, this is certainly not from here. The domain is certainly it's different. So here R. So this can't be a sequence. And similarly, okay, certainly for F2 is correct because here the domain is set of all natural number. And again, F3 can't is incorrect because this domain is negative.
It's a negative real line.
Yes, and F4 is same kind of similar argument, and F5 is basically it's a map from N to Z. Okay, so since this is a map from N to Z, I can also consider this as a function from N to R also, right? Because Z is a subset of R.
So yeah, I was about to say that subset of it. Yeah.
So I can consider this function F5 as a function from natural number to R1. In that case, my F2 and F5 there, so they basically represent a sequence. So I guess, yeah, this is the correct answer. So again, let me repeat. So sequence is nothing but it's a function from the set of all natural numbers to R. Yeah. Okay. So this part is clear. Okay. So let me come back to the limit of a sequence. Okay. So suppose you have a sequence, right? So this is my sequence, and as I said, sequence. So basically this, when I'm writing this is basically I have A1 and I have A2, I have A3, and this goes on. Okay, so up to infinity. So I have this number.
No, sir.
Yeah,
They're
so
up to AN, not infinity, no, sir.
So what is n?
It is the last
So
member
it
of
is
the
infinity,
set.
na?
N.
It is infinity, na?
So n actually, if you see, n varies over what? So I have written something over here, right?
No, there is the n will have a limitation, isn't it, sir?
No. So as you can see, n basically it's a member from the set of all natural number. Okay. So is there any limit for the set of all natural number? There is.
Negative numbers are the limits.
No, I'm saying upper bound. Okay, not the lower bound. Okay, so certainly natural number, all the natural numbers are greater than 0. I'm saying about, is there any number which basically you can bound all the natural number by that number? So natural number goes up to infinity, right?
Yes, sir.
So that means you don't have anything. If you have an, then the next term will be an plus 1, right? Then an plus 2,
Okay.
n plus 3, so on. It will go up to infinity. Okay. So there is no limit. So that is what, so if you see, that is the main idea. You have a function from n to r. Okay. So this n has no limit. So that's why the sequence, it has no limit. Okay. So this is okay. So in some sense, so even if I tell that this is my sequence, then you can think of the sequence as some list of numbers with some particular order. That A1, this is my first term. What is the meaning of that order actually, basically? So there is in some sense, there is no order, but this is my first term. Okay, this is the first term of the sequence. This is the second term of the sequence. This is the third term of the sequence. And this is the nth term of the sequence.
Sir, I have a doubt.
Yes, please.
Will a finite set never be a sequence?
No.
So sequence will be always infinite.
So what do you mean by finite number?
So you gave some example like 1, 2.
Hmm.
So I'm confused.
So if I just write 1, 2, right? Just write 1, 2, then certainly this can't be a sequence. This is A1, right?
Yes, sir.
This is A2, right?
Yeah.
Then what is A3? What is A3? No,
Not the family.
there is nothing called A3. That means what? I don't have a, so in particularly, as I said, try to understand this as a function. So when I'm saying that A3 has nothing, so that means 3 has no image, right? 3
Yes.
has no image. 3 has no image. That means this can't be a function from the set of all natural number to R. When I'm saying A3 has no value, that means 3 has no image. So that means this can't be a function. So again, if you are saying simply 1, 2, then certainly this can't be a sequence. Okay. But again, I can create a sequence out of one number only. Okay. If I write this 1, 1, 1, 1, and so on. This is a sequence. I have created a sequence out of just a single number. And if you see, this is a sequence because this is my A1 is 1, my A2 is also 1, my A3 is also 1, my A4 is also 1, my A5 is also 1. So all AN are basically 1. So this, in some sense, this is a constant map. Okay, so this is a constant map. This sequence is nothing but it's a constant function. F of x is equal to 1 for all x in n, right? But so instead of writing like this, if I simply write 1, okay, so 1 is not a sequence because what is there after 1? Because there is nothing after 1. This is just my A1. But then what is my A2? There is nothing for my A2. So this can't be a sequence, right? So this is a sequence. I can create a sequence just by a single number. Okay. So for example, I can create sequence. Let's say this is my sequence. For example, I take 2 pi 3, let's say again 2 pi 2 pi and so on. This is a sequence because my A1 is 2, my A2 is pi, A3 is 2, A4 is pi, and so on. Sort of repeating. This pi, 2 pi is appearing all the time. Okay.
Periodic function, no, sir, for this.
Yes, in some sense you can say it's a periodic function, but yeah. But okay, so you have to sort of define. So in some sense this periodic function, okay, in some sense makes sense when the domain is R. Okay, so
I just said it like for
yeah.
I hope you got it.
I understand your point. Yeah, but okay, so this is some sense discrete. So yeah, so it's basically it's appearing again and again. 2 pi, 2 pi, 2 pi, 2 pi. So one way of saying this sequence, as you can see, I can write this sequence in the form of function. Okay. So as you can see, if I write my sequence, that is f of n is 2 if n is odd, and f of n is pi if n is even. So this sequence, I am representing this sequence as a function. So this and this, they are basically the same. Okay. So I'm representing this sequence as a function. So again, if I have only just 2 numbers, then certainly these 2 numbers, they can't be a sequence. Okay. But I can create a sequence out of 2 numbers. Okay. I can create a sequence. I have 2 numbers. If I have only 2 and pi, then certainly this is not a sequence. But I can create a sequence out of this. This is a sequence.
Okay, thank you, Sugam.
Yeah. Okay, so okay, so I wanted to discuss this limit of a sequence. Okay, so so I have this sequence. Let me come back. So this is my sequence. So I say that, so suppose this is a sequence. I say that the limit of the sequence of this sequence is A. So we say that the limit of this sequence, limit of this sequence is A, when I can say, so I can say that the limit of the sequence is A. So if I increase the value of n, okay, if I increase the value of n, then the value of an, this value of an will come closer and closer to A, right? So in other words, what basically it's saying, if I take 10, okay, so then A10, we have A10, And again, if I take 11, I have A11. Okay. Then for maybe say 100, I have A100. 100. So as you can see, I'm increasing the value of n. Right? I have 10, I have 11, I have 100. So if I increase this value of n, if I increase the value of n, okay, this if I increase, then this number A100, then I will get something else. This number will come even more closer to A. Okay. For example, if I take this sequence, for example, if I take my sequence an is nothing but 1 by n, right? This is my sequence. So as you can see, this sequence, the limit of this sequence is 0. The limit of the sequence is 0 because if I increase the value of n, if I take n to be 10, then I am getting 1 by 10, right? Okay, so the difference between 0 and 10 is basically 1 by 10, right? But if I increase the value of n by, let's say, 10 to 100, then I am even coming more closer to 0, because 1 by 100 is even more closer to 0. Again, if I increase the value even further, maybe say 5,000, I am getting 1 by 5,000. So if I increase the value of n, as you can see, this an, this is a 100, this is a 5,000, they are coming even more and more closer to 0. Okay, so that is the whole idea of this limit. So I say that I have a sequence, and the sequence has some limit a. So that is basically the meaning of the statement is, if I increase the value of n, then the terms of the sequence will come closer and closer to this number a. Okay, and I say this, then I say the sequence is a convergent sequence, and the limit of the sequence is a. Okay, and if I have a sequence for which I don't have any such a, okay, if I have some sequence for which I don't have any such a, like if I increase the value of n, then the terms of the sequence, they are not coming to some particular point a. Okay, if I increase the value of the sequence, then the terms of the sequence, they are basically not coming to any point a. Okay. In that case, I say the sequence is divergent sequence. Let me give you an example. So suppose you take this sequence. So you just now you see that if I take this sequence, then it's clear that if I increase the value of n, then the terms of the sequence, they are coming closer and closer to 0. Okay, so that's why this sequence is convergent sequence. This is a convergent sequence, and the limit of the sequence is 0. Okay, so in other words, this limit n tends to infinity, this sequence an is basically 0. Right? So that is, in other words, so basically this is what we use to tell that the limit of the sequence is 0. But okay, so maybe this sequence is something special for which I can get some a. Okay, a that if I increase the value of n, then all the terms of the sequence, they are coming closer and closer to 0. Okay, so it may not, so this type of case may not be true for all the sequence. So I may have a sequence where the terms of the sequence, they are not coming closer and closer to any particular point. Okay. So for example, you take this sequence. An is basically minus 1 power n. N equal to minus 1 power 1. So as you can see, your A1 is minus 1, right? A2 is 1. A3 is
Again, minus 1.
minus, and sort of repeating thing. Okay. So as you can see, if I increase the value of n, okay, sometimes it's going to 1, sometimes it's going to -1, sometimes it's going to 1, sometimes it's not, it's coming to -1 again, and again going to 1 and coming to -1. So as you can see, what doesn't matter how much you increase the value of n, okay, it's always oscillating in between 1 to -1. Neither it's going towards 1 nor it's going towards -1. Okay. So there is no such a to which the sequence is going closer and closer. Okay. For example, here you have 0. You have number 0. If you increase the value of n, the sequence is coming closer and closer to 0. But in this case, that is not happening. Okay. If I increase the value of n, neither it's going to 1 nor it's going to -1. Okay.
Yes, sir.
So that means this, for this sequence is basically it's, so the, for this
Divergent.
sequence, yeah, it has no limit. So that's why it's a divergent. This is a divergent sequence. So, so let me take one more example. Let's say this is my sequence. So can you tell me what will be the limit of this sequence?
1.
1, sir.
1, right? Because
1.
if I increase the value of n, okay, suppose I'll take, this is my a1, and this is certainly a1 is 2, then a2 is 1 plus 1 by 2. Okay, so this is 2, this is 3 by 2. Okay, it's going, yeah, it's coming down. Okay, and then this is a3, which is 1 plus 3, right? And as you can see, if I increase the value of n, then this 1 by n, right, it's basically going towards 0. That means my whole an is coming closer and closer to 1.
1.
Right. So that means this is a convergent sequence, and the limit of the, yeah. So the limit of the sequence is 1. Okay. So okay, let me go back to some activity question. Yeah. So you can see this thing, right? Okay. So okay, let me do some more question probably. So let's say this is my sequence. Now the sequence, the term of the sequence is basically, let's say 1 by n, right? 2 plus n. Can you tell me what will be the limit of this sequence?
1, sir.
Why? Hello?
Yes, sir. Limit would be 1.
Why?
Sir, why 1 by 2? If we take n common from numerator and denominator, so we are getting 1 plus 1 by n. So on the numerator, if we increase the value of n, so the 1 by n tends to 0. So numerator part is sorted. In the denominator as well, if we take n common, so the 2 by n also tends to 0. So it's 1 by 1, so 1.
Correct. Yeah. So okay, so in some sense, what I can write this as, so I can write this as 1, 2 plus n minus 1, right? The numerator, right?
Yes, sir.
And this is same as 1 minus, right?
Yes, sir. We can write this.
So again, the same idea, right? So if I increase the value of n, this thing will come closer and closer to
0.
0. That means my whole term sequence an will come closer and closer to 1, right?
Yes.
And as Santan, he basically suggested, instead of doing this, we can divide this denominator and numerator by both by n. Okay, so if I'll do that thing, then what I'll get, this divided by 2 plus n by n. Okay, so in that case, what I will get, this is basically what?
1 plus 1 by n.
1 by n and
One,
2 plus
Sir, 2 by n plus 1.
2 by n plus 1, right? So as you can see, so now this is my sequence. So it's basically I'm writing the same thing in some different form. Okay. So as you can see, if I increase the value of n, this thing will come closer and closer to 0, right? And this thing as well, 2 by n, will come closer and closer to 0, right? That means the whole thing will come closer and closer to, this whole thing will come closer and closer to what?
Once.
Because yeah, so since this 1 by n is going closer and closer to 0, that means 1 plus 1 by n will come closer and closer to 1. Okay, that means your numerator will come closer and closer to 1. And the second thing is the denominator, you have 2 by n is coming closer and closer to 0. That means 1 plus will come closer and closer to 1. So both denominator and numerator, they are going closer and closer to 1. So that means the quotient will come closer and closer to 1. So that means this is the limit of this sequence. Okay, so now let me ask this question. So question number 2. So what will be the limit of this sequence? How you can solve the limit of this sequence?
The same approach, sir.
Same.
If we take n square common from the numerator and denominator, so we are getting 3 on the numerator, 3 plus 5 by n plus 2 by n square. So the n parts, as n tends to infinity, those terms are tending to 0. So those are sorted. Same as denominator.
Absolutely.
6 plus 2 by n plus 1 by n square. So it's 3 by 6, which is half.
Yeah, so let me write what San just now said. So this is my sequence, the nth term of my sequence. Okay, so my sequence is an. Let me. This is my sequence, and the nth term of the sequence is given here. And what is that? 3n square plus 5n plus 2 plus 2. Okay, so what I'll do now, I'll try to divide n square in both denominator as well as numerator. So if I do that thing, then what I will get, if I divide n square in the numerator, what I will get, 3 plus 5 by n
Plus 2 by n square.
2 by n square, correct. And similarly for the 6
Plus 2 by n plus 2 by n square.
Yeah. So one thing you can notice now, if I increase the value of n, that means if I take the value towards infinity, okay, in some sense, if I increase the value towards infinity, then this thing, this 2 by n square will go towards 0, right?
Yes, sir.
And similarly, this 5n will go towards 0 as well. And this 2 by n also will go towards 0, and 2 by n square will also go towards 0. That means my denominator is going towards 6, right? This thing is going towards 6, and this numerator is basically going towards 3. That means my whole quotient will go towards 3 by 6. So that means the limit of the sequence is 3 by 6, which is precisely half. I'll come to this maybe sequence, subsequences. Okay, what about question number 7? What about question number 7? So now this is slightly trickier one. What will be
Sir.
the limit?
Sir, rationalizing, sir,
Yeah, correct.
approach.
Yes. So so it's, if you try to, the problem with this question, if you try to do it directly, then it's you can't, most likely you can't go anywhere. Okay, so instead of doing that, you just need to rationalize the quotient. Okay, so this is let me go back to the different slide.
Divide by.
Yeah. So my sequence, the nth term of my sequence is, so this is my sequence, right? I guess n plus, what is n plus 1?
The 2n plus 1
Okay, 2n plus 1 minus 2.
minus root over of 2n.
So what I can do?
Multiply and divide by root of 2n plus 1 plus root of 2n.
Correct.
Sir, just a small question, sir. I actually don't remember the term. So we call it a conjugate value, right?
Which one?
I mean, the when we are rationalizing, so
Hmm.
we call it the conjugate value of that particular thing, right?
No.
Because I
It's
don't,
not.
I actually don't remember the term
Actually,
actually. I mean,
no. So when you actually, you can, no, there, as far as I remember, there is no such term. Like when actually you are dealing with complex number, right?
okay.
So in that
Okay,
case,
so I
actually,
mixed it up.
you can say that you just need to apply the conjugate, because for real number the conjugate is basically the same thing. Okay.
Yeah. Okay, sir. I just got confused. Okay, sir.
Yeah. So this is so now so eventually what I'm getting 1. Right? This is what my sequence is. Now I can easily say what will be the limit of this sequence. So again, like what is the limit of this sequence?
0, sir.
0, right? Because as you know, like if I increase the value of n, if I increase the value of n towards infinity, then certainly square root of n will also go towards infinity only. Okay. So if square root of n will go towards infinity, then certainly 1 by square root of n will come, see, if n square root of n is
It will tend to 0, sir.
yeah, becoming larger and larger, then 1 by square root of n will come closer and closer to 0. So as you can see, I have 2n plus 1, square root of 2n plus 1, and again I am adding one more square root of 2n. Okay, so I have something, if I increase the value of n, then this will increase as well as this will increase. That means all the quotient will both. So basically the denominator will also increase, and that means the 1 by that number will go towards 0. So this is the limit of this sequence. Okay, so I guess so there are a lot of things you can do with limit of sequence, and certainly it's in many cases actually it's not that easy to find the limit of the sequence, because here actually it's more or less you can see what you want to do, but in some sequences it's extremely difficult to find the limit of the sequence. Okay, so just last thing I want to discuss is basically I want to tell you something about subsequences. Okay, so it's more or less I want you to solve, at least I want you to solve if some sequence is given, then whether you can tell whether that, sorry, yeah, so if a sequence is given, you can, at least you should able to tell that whether that sequence is a subsequence of some another sequence or not. That is what I want to explain. So, okay, so let me tell you some, in some sense, the vague definition of subsequence. Okay, so okay, so let me write this. This is actually really, this is important. Subsequence is basically, it's a sequence. Okay. So subsequence is a sequence that can be derived from another sequence, or let's say, instead of saying another sequence, I can say the original sequence. Okay, a subsequence is a sequence that can be derived from the original sequence. Okay, by just deleting some elements without, this part is really important, without changing the order of the remaining elements in the original sequence. Okay. So this part is really important. Okay. Without changing the order of the remaining elements in the original sequence. Okay. So okay, I have written some statement, or maybe say definition. So let me try to solve, like, not solve. Okay, let me try to explain this definition using some examples. Okay, so let me take the first, let's say this is the obvious sequence. Suppose my sequence is what? This is my sequence, and how I define my sequence? My sequence is basically an is equals to n, right? This is my sequence. So then what is my sequence? Basically, my sequence is 1,
1, 2, 3, 4 till infinity.
4, 5, 6, so on. Okay. So the question is whether, so this is my sequence. This is my, in some sense, this is my original sequence. Okay. So my question is whether this sequence 1, 1, 1, 1, whether this sequence is a subsequence of this original sequence. So you have definition here. A sequence is a subsequence is a sequence that can be derived from another sequence by deleting some elements of the original sequence without changing the order of the remaining elements in the original sequence. So my question is whether, so if you you see this definition. So this is my definition of subsequence. So by using this definition, can I say that whether this is a subsequence of my original sequence? This is my original sequence.
No, sir, this is not a
No, sir, it's not.
subsequence.
Why?
Order is not maintained, no, sir. If
It's
after
not.
after one, you can either have 2, 3, 4 in the next sequence.
So the thing is, okay. So let me now certainly forget about order. Like so if you see the definition, actually you are doing two things, right? First, you are applying two things to the original sequence. You can delete few elements, okay, and at the same time you have to maintain the order also, right?
Yes, sir. And in this case, sir, you're duplicating one element into multiple times, which is not allowed.
Which is not allowed, because basically what actually if I delete few elements in my original sequence, okay, if I delete few elements in my original sequence, then I will never get this sequence, because as you can see in my original sequence, this one is appearing only once, right? Only once, right? So if my in original sequence one is appearing only once, then certainly in my subsequence, then one can't appear infinite more than one time. Okay, so one can only appear at least one time. Okay, until unless I am not removing one from the original in my subsequence. Okay. So this sequence, this is not a subsequence. So okay, instead of taking this one, let me take one more example. Let's say 1, 3, 5, 7, 9, 13, 11, and so on.
Yes, as I
Not a
told, no,
subsequence, sir.
the order is not there. After
Order
9,
is not
11 should
maintained,
come.
sir.
Correct. Good, correct. And this is what I wanted to know. As you can see in my original sequence, if you go, okay, so it's fine. Like by deleting some elements, okay, if I delete some elements, I can get the sequence. Okay, if I delete some elements from my original sequence, I can get this sequence. But the problem is I have one more condition. So when I'm deleting some elements, I have to make sure that I'm not changing the order of the remaining elements. But here, as you can clearly see, I'm changing the order of the elements. Okay, changing the order, because in my original sequence, if I see my original sequence, then actually 13 will come after 11, right? 13, I have 11, then I have 12, then I have 13. So 13 is coming after 11. But in my subsequence, as you can see, 13 is coming before 11, which is not allowed, because I can change the order of the sequence, okay, of the remaining element of the sequence. Okay, so that's why this is not a subsequence, not a subsequence. Okay, instead of this, okay, let me take one more example. Okay, so once I take, like, yeah, so suppose I take this one, 1, 4, 16, okay, 1, 4, 16, I guess
25.
not 25, 1, 2 square, sorry, this is
Okay, 2 to the
this is 9,
16,
16, then 25.
25,
So
36.
on. Yeah. So what about this one? Whether
Sir, this is a subsequence, sir.
This is a subsequence.
This is a
Yes.
subsequence, sir.
As you can see, actually if you see, I'm deleting lot of elements from the original sequence, and as well as I'm maintaining the order. And first I'm taking this one, then I'm deleting this one, then I'm taking this one, I'm deleting this one, I'm deleting this one, I'm deleting 7, I'm deleting 8, then I'm taking 9. Okay, but again, as I say, I'm deleting lot of elements from my original sequence, and at the same time I'm making sure that the order should be preserved. Okay, so here I'm deleting elements and as well as the order is preserved. So that means this is a subset. This is a subset. Okay, so okay, let me take one more example. Let's say I have some new sequence. So my original sequence is what? My original sequence is 1 by n, right? So that means my sequence is 1 minus
Sir, it
1.
will be -1 starting, sir.
Yeah, correct. Sorry. Yeah. And so my question is whether this is a subsequence of the original sequence.
Yes, sir, it is
Yes, sir, it
subsequence
is.
of
It is
first equation.
subsequence.
Correct.
You're changing the n to 2n.
Correct. So basically, in some sense, I'm starting with 1. Okay, let's say I'm starting with this one. Okay, right? And as you can see, I have a 1 after this one, right? I have a 1 after this one, right? So I have a 1 after this one. So I can take this one. I can take this one over here. Again, I have another one after this one. Okay, I have another one after this one. Again, I can take this one. Okay. So this is a subsequence of the original sequence. And similarly, the same logic, I can say that this is also a subsequence of my original sequence. Okay. And what about this one? Let's say, suppose I am taking 2, 1, 1, 1. Is it a subsequence of this original sequence?
No, sir.
No,
As per
sir.
the first definition, first part of definition, it is not there, sir.
Yeah. So
Because
because
that item is not there.
so basically certainly 2 is not in this original sequence. So since 2 is not in that original sequence, then certainly 2 can't be in my subsequence. So okay, so I guess now you know. So let me solve this some question from the activity part. So let me solve. So more or less, I solved this option, question number 5, right? Right? Because
Yes, sir, you did.
Yes, sir.
this is certainly, we know that this is a divergent sequence, right?
Yes, sir.
So so that means divergent
Limit,
means
limit doesn't exist, sir.
correct, limit doesn't exist. Okay, so all these things are incorrect. And as you can see, this is a subsequence. This part is a subsequence of my original sequence. So now come to this question. Okay, so come to question number 3. Okay, so my original sequence is this one. Okay. So what about option 1? Whether
It's
option
not
1
a
Not
sequence
a
because
subsequence, sir.
2 is repeated.
yeah, 2 is
Not
appearing
a subsequence.
correct. So 2 is appearing once in my original sequence, but in my subsequence 2 is appearing infinitely many times, which is not allowed. Okay. And clearly option 2 is a subsequence, right?
Yes,
Sir, it is.
Basically what I am doing, I am actually ignoring all the odd natural numbers. Okay, I am ignoring 1, I am ignoring 3, I am ignoring 5, I am ignoring 7. And as you can see, I am ignoring all these elements, and whatever I am taking with the proper order. I am not changing the order. So as you can see, I have 2 in my main sequence. I have 2, and 4 is actually appearing after 2, and that is what I am maintaining over here also. okay, in my subsequence, and 6 is appearing after 4, and the same thing I'm maintaining in my subsequence as well. 6 is appearing after 4, and the same process. Okay. And what about option 3?
Not a subsequence.
Not a subsequence, sir. Order is
Order is not mentioned.
disturbed.
Yeah, because if you see, as you can, there are two problems. Okay, as you can see, 10 in my subsequence 3, in my original sequence, 10 is appearing only once, right? In my original sequence, 10 is only appearing only once, right?
Oh, and here it is happening twice actually.
Appearing twice. And one more problem also, I'm not maintaining the order. Okay, here 10 is appearing after 4, right? But here, as you can see, 10 is also appearing before 4. Okay, certainly 10 is appearing after 4, but as well as 10 is appearing before 4, which is not allowed. Okay, because if in my original sequence, if 10 is appearing after 4, then in my subsequence also I have to follow the same thing. And what about option 4?
It is a subsequence, sir.
Yes.
It is a subsequence, right?
Yeah, yeah.
Basically, yeah, you can see what I'm doing here.
Only taking odd terms, sir, from the sequence.
Yeah. In some sense, not odd, I am actually ignoring 1.
Ignoring 1, yes, sir.
Yeah.
Like the condition is 2n plus 1, sir. Yeah.
Yeah. So I am basically ignoring 1, 2, then I am taking 3, then I am ignoring 4, then I am ignoring 6, then I am taking 7, then I am ignoring 8. So as you can see, I'm deleting lot of elements, and at the same time I'm maintaining the order also. Okay, as you can see, 3, 5 is coming after 5. Here also 5 is coming after. Sorry, 5 is coming after 3. Here also in my subsequence 5 is coming after 3. 7 is coming after 5. And here in my subsequence 7 is coming also. And similarly, I'm maintaining all the order of all the elements in my subsequence. Okay, so that's why this option 4 is a subsequence.
So can we safely say that from your examples and this, for the new sequence, there should be one n. If instead of an, if it is becoming bn, n is modified in different ways. Like maybe in the option 4, it is 2 times of n plus 1, and in option 2, it is 2 times of n. So
no, it's certainly not 2 times 7, because at the same time you can see I'm ignoring lot of elements, right?
yes, sir. That is what I am telling. 2 times of n in option 2, which means for all a of n's, if a of 1 is taken, then subsequence will be 1 into 2. That will be a of 2. So that is why you got 2. In for if a of n, if for example you are having a of 4, which means in b of it will become 8. Something like that. Correct, no, sir? We can say that. Can we safely say that?
In some sense, but okay, so these are that is not the complete
True for all.
No, yeah, that is not true for all, but certainly whatever you are saying is true for this option 2 and option 4. I can create lot of weird subsequences. Okay, so that will not follow the whatever pattern you are saying. Okay,
No,
but again,
so far, whatever the examples you have shown and whatever we have discussed, in all the examples, this pattern is being followed, sir.
Yes. So again,
can you show some pattern or some example where this pattern is not followed?
No, as I said, like you can take, suppose you can take like, so okay, just give me. So again, like, so this is one.
Can it just be a subset and not follow any of the formula or a definition for n?
So that certainly you can do that, right? So what I'm saying, 8, 9, 10. This is my original sequence. Okay. So what is my subsequence? I'll take 2 first, right? Then I will take 3. Then I will take 5. Then I will take 7. Then I will take 11. Then I will take what? Can you tell me what will be the next?
13, 13, 17, 19, 23.
Yes. And so on. So can you see what is actually my subsequence? So this is a subsequence. Is it? Is it a subsequence?
Yeah,
Yes, sir.
following
because-
both the
Most-
conditions
because
of the definition.
Yeah, basically I'm taking the primes. Okay, all the primes. Okay. So I'm taking all the primes without changing the order, right? So this is a subsequence.
Yes, sir. In that also you can say, no, sir, B of n, the function can be defined as for all n which is prime.
No. How? What will be the what is the Bn?
Bn for an, whatever n is there, in that n, an of prime and others.
No,
Okay.
that certainly that has no meaning, like whatever you are saying.
Okay.
So
Yes, sir. Yes, sir. Okay.
so
Correct. I understand.
yeah. Again, this is slightly like as you can say this is also in some sense you have some concrete idea about the subsequence. Okay, you may not define it, but certainly you have a concrete idea, right? That I'm taking some prime number.
No, for a function, see, any set, I mean, sequence, for original definition of sequence is from sequence of numbers, you can make it as a function. And from function, you can bring it as a sequence. For these examples of primes, what will be the function, sir?
So basically what I'm saying, basically the function is basically what? I'm taking f of n to be the nth prime, right? The nth prime, right? That means what is f of 1? F of 1 is the first prime, right? Which is 2, right? What is f of 2? F of 2 is my second prime, which is 3. What is f of 3? F of 3 is my third prime, which is 5. So this is my subsequence. This is A1, this is A2, this is A3, this is A4. As I said, this is again, this has also some, you have some concrete sense about your subsequence. Okay, again, like as I said, you can like whatever number you pick if in some increasing order, that will be a subsequence of that of the sequence, right? Whatever
Correct.
number you arbitrarily you pick whatever number, but in some increasing order. Okay, that will be a subsequence. Right? I pick
Okay.
1, then okay, someone said 13, I pick 13. Then someone said you pick 20, I pick 20. Then
44, 42,
40,
whatever it is in that
44.
increasing order.
Yeah, you maintain an
There is
increasing order.
there is no relationship between A1 and A2, or comparatively, there is nothing in ratio or whatever terms. A2 and A3 is not having relationship compared to A1 and A2.
Yeah. Pick anything, you pick 44. Someone said I will pick 1,000 now. Okay. Again you pick some another number which is greater than 1,000. If you maintain this order and if you keep on going, then you will get a subsequence of this original sequence, because you are not violating any of these two conditions. Okay, you are deleting elements, and at the same time you are also not changing the order. Okay. So again, like for this kind of set, you certainly you can't define some concrete rule.
Function.
Yeah, correct.
Okay, sir. Now I got it.
Yeah.
So I was thinking any subset should have a relative function with respect to the original function. So that is not there in definition.
But you certainly see you can define it. You can define it as a function. Okay, this is also a function. But what you have to do now, you can't write this like this. Okay, f of n is equal to 2n, or maybe f of n is equal to 5n. You can't write like this. Okay,
Yes, sir.
you have to define one by one. Okay, because
Yes.
you don't have any general formula. You have to define f of 1 is 1, f of 2 is
Of 2 is, yeah.
13, like this. Okay, certainly this
Okay.
is a function. Since this is a sequence, this is a function. But you don't have some concrete formula like this. Okay.
Relationship.
Yeah, correct. You don't have any concrete relationship like this. Okay.
Okay.
It's-
And with same thing, I have one more doubt, sir. Sir, any of the subsequence also should go to infinity, no, sir? Or it is a requirement or not a requirement?
No. It's depend on the sequence. So, if you see, if you go in,
Now infinity matlab n has to be infinitive.
yeah, certainly.
an.
No, you can't stop there, right? You have to go
Yeah.
to infinity. Okay, it has to go to
Even
infinity.
Okay, subsequence also that n will, after n plus 1 will be there, n plus 2 and n plus keep on going.
Yes.
Yeah, sure.
Yeah.
Nice, sir. Thank you very much, sir.
But certain, yeah. So the thing is, yeah. So this n, definitely the n has to go towards infinity. Okay. You can't stop up in some finite states.
Sure.
Okay, so let me solve the last question, like related to the subsequence. The last question that I wanted to discuss, this particular question. Okay, so can you tell me what will be the subsequence of this sequence? So my original sequence is n square. That means
N square and 2n square would be the subsequence.
that means my sequence is basically 1 square, 2 square.
2 square, 3 square.
Yeah, correct.
And the sequence is a subsequence of itself. So n square would be a thing.
Correct.
And 2n square would be there as well. For any sequence value, if we take that it satisfies the condition. Let's say
So
2
yeah,
square.
okay,
We are getting that.
yeah, correct. So n square is a sequence, is a subsequence of itself. Okay, if this is my sequence, then basically if I write this also, this is also a subsequence of this sequence. Okay, this is also a subsequence because they are basically the same thing. Okay, so I am deleting nothing. Okay, so I am deleting nothing, and by deleting nothing, I am getting the same thing. Okay, so basically this is also a subsequence of the original sequence. So the same sequence is a subsequence of itself. Okay, so that's why n square is a subsequence of n square. Okay. And what about this one, option 1? Okay, so if you write option 1 first, if you try to write it, what actually you will get? What is option 1? What is this sequence? This is basically 6 square, 7 square, 8 square, 9 square, and so on. Whether this is a subsequence of the original sequence?
It is a subsequence, sir.
Correct. What about option 2? Right? If we write option 2, then what actually I am getting?
So
1,
still, sir, it
Three-
is 3 square,
three
4
cube.
square, 5 square.
3
3
square, I
square,
guess,
4 square, 4.
not
Oh,
4,
sorry, 5, sorry.
5 square, 7
Odd.
square,
7 square, 9 square.
Okay. Again, I am deleting lot of elements, and at the same time I am maintaining the order. So this is a subsequence. This is a subsequence. What about option 3?
So it's cube, sir. So it doesn't satisfy the original sequence.
Yeah, so
You do not
basically
have to-
if I pick 1 here, if I put n equal to 1, what I am getting? 1,
No, chess,
Three.
I'm
3 power 3, right? 27.
yes, sir.
But
Yeah.
as you can see, 27 is actually is not in this
The
original
sequence, sir.
Yeah, 27 is not in the original sequence. So if you see 14 square, then you have 5 square, which is 25. Then you have 6 square, which is 36. So 27 is not appearing in this original sequence. And here 27 is appearing. So this can't be a subsequence because you have 27 here, which is not in my original sequence. What about option 4?
Same logic, sir.
Yeah.
It's not, I mean,
Okay. So
from
can
original sequence
Gaurav?
Cube itself is not there.
Yeah. So again, like same logic. Yeah. As you can see here, you have 1 cube and again 2 cube, which is 8. 8 is not in original sequence, my original sequence. And obviously option 5 is correct because n square. And what about option 6? 2n square. What I am
This is
taking?
correct, sir.
Correct, right? Because what I actually am doing. So basically 2 means
There are
2
4
square.
into 1 square
Yeah.
and
4 square.
and then sir 4 then 4 into 2 square, that means
Yeah.
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 Sequence.
Yeah. So again, like one more thing. The last one is option 7 is incorrect. Okay, because if I take n equal to 1.
1.5 square.
Yeah. So basically, if I take n equal to 1, then basically what I'm getting 3 by 2 square, right? 3 by 2 square. 3 by 2 square is certainly it's not in original sequence. So this is not a subsequence. Is there any doubt in this question? Okay. So is there any other doubt which you want me to address?
Sir, the greatest integer thing, sir. That one.
Hmm.
Like if you have time today.
What you want me to discuss about greatest integer thing?
Sir, for like for any value. Okay,
Any?
this is getting too loud over here. I can't even talk. Okay. So can you hear the background noise? People are getting loud over
Yeah. I can. But what is your question? I just.
here. Sir, the question is greatest integer in the sense like the floor functions and all that. I mean, for let's say if we are taking like for any like from left hand side limit and right hand side limit, if we are taking for two different values, I mean we are not concerned about the limit, but we are actually trying to like calculate something. Like vaguely, I'm trying to say it's not like I don't have exact like anything. So the thing is, if like the limit value from the left side is let's say something, and
Yeah. So let me discuss.
units or something,
Um,
it's like in class or something, how to calculate such problem. That's my actually issue.
okay. So let me discuss that thing. Okay. Now I'm not. Yeah. So if you draw the graph of the let's say greatest integer function. Okay. So the greatest integer function is basically in the interval 0 to 1. It's basically 0, right? So we are not considering 1 over here. Okay.
So one would be open circle.
Yes, 1 would be correct. So again, this is 1 to 2, and again 2 is open, and this is 2 to 3. Again 2, 3 is open. Okay, so this is my 1, and this is my 2. So okay, so let me take some fixed point. Let's say 1. I want to compute the limit of this function at 1. Okay, that is my main aim. So to compute the limit, I need to find the left hand limit, right? At x equal to 1, because I want to check the limit of the function at x equal to 1. So for that I have to first compute the left hand limit. Then I have to compute the right hand limit at x equal to 1. I have to check these two things, and then I have to check if the left hand limit is same as the right hand limit. Then basically the function has a limit at x equal to. Now, so for the left hand limit, what I need to check to check whenever I'm coming to this point 1, this is my 1, when I'm coming to this point 1 from the left hand side, okay, when I'm coming to this point 1 from the left hand side, where the function value of the function is going. If I am coming to 1 from the left hand side, where this value of this function is approaching, where this value of the function is approaching. Okay. Now if you see, suppose I'm coming to 1 from the left hand side, that means let's say this, I'm coming through these points 1 minus 1 by n, right? So this is basically all these numbers are less than 1, so that's why I'm coming using this sequence to 1. That is basically I'm trying to coming from the left hand side. So if you see, then the function value 1 minus 1 by n is basically 0, right? It's basically 0, because if 1 is less than this is basically in between 0 to 1, so at that point the value of the function is basically 0. So in some sense, when actually I'm coming to 1 from the left hand side, my value of the function is approaching towards 0, as you can see here, the black line. So when I'm coming towards 1, as you can see, this is basically this whole thing is coming towards 0. Okay, so when I'm coming x equal towards 1 from the left hand side, the value of the function is basically approaching towards 0. So that is my left hand limit. So left hand limit of this function at x equal to 1 is 0. Now again, to check the limit, I have to compute the right hand limit as well. So for the right hand limit, what I have to check, I have to compute, I have to see when I am coming to 1 from the right hand side, where the value of the function is approaching. And it's clear, like if you see the graph, then basically it's clear that the value of the function is approaching towards 1, because if you are coming towards 1, then the value of the function is basically it's there.
Yeah, it is approaching to
1. Yeah. So that means the left hand limit at 1 is 0, whereas the right hand limit at 1 is 1, right? So the right hand limit is basically at 1 is basically 1. Okay. So certainly the right hand limit and left hand limit, they're different. Okay. So that means at this point 1, the greatest integer function doesn't have any limit. Okay. And basically the same thing is happening in all the integer points. Okay. If I pick 2, then the same thing is happening. The left hand limit, if you see, the left hand limit is 1, whereas the right hand limit is 2. Okay, and since for this 3, it's the same thing. The left hand limit is 2, the right hand limit is 3. Now is it clear now?
Yes, sir. Yes, sir. Yes, sir. It is clear. Thank you, sir.
Yeah. Okay, is there any other doubt? Okay, so then I'll stop the session now. Okay.
Sir,
Thank you very much, sir.
if you have time, then activity 7.3, if you have time, sir.
7.3 what?
Sir, question number 6 and 7 and 8.
No, let me solve maybe one question. But I am not going to solve 3 questions now.
Sir, question number 7, sir.
Yeah, this is pretty easy, right? So in some sense, when there is no tangent at a point, when there is a corner point, right? So this is, as you can see, this is a corner point. Okay. So you will see why actually. You will see why in week 8. Okay, but
Yes, sir. That's why I was asking, sir. This is the
why?
reason.
No,
Yes, sir.
now you try to take it as a fact. Okay, so when you have some corner point, then in that case you don't have tangent. Okay, you'll see once you read differentiability. Okay, in the next week.
Sir, it is the concept of the left-hand derivative and the right-hand derivative, is it?
Correct. Because when you are actually taking the left-hand limit, okay, so left-hand derivative, actually in some sense you are getting the slope of this line, okay, and when you are taking right-hand derivative, you are basically getting slope of this line, okay. So that's why the left-hand derivative and right-hand derivative are different, okay. So that's why this function is not differentiable at this point P, and that's why you don't have tangent. So in some sense, okay, so that is the thing that you'll see in week 9. But for now, you try to think as P as a corner point, okay. In some sense, you have a corner, right? So if your graph is something like this is smooth, you don't have any corner point, okay. That means here at all these points you have tangent, okay, but that is not the case over here. You have some few points that are basically corner points, P, Q, R, S, okay. So at these points you don't have tangent, okay.
Yes.
Yeah, so okay, so this is sort of easy, and let me do. Now you can do question number 8, right?
Yes, sir.
Because see, certainly this graph is sort of incomplete, okay, so you don't know what is going on beyond this point, okay, because it's sort of a finite part of this. So as you can see, you have 4 points where the derivative, you don't have tangent, okay. So
Yes.
at least you know you have 4 points. So that means the lower bound is basically 4, okay.
Yes, sir.
And okay, so let me solve question number 9 as well. So what is the graph? What is the graph of a function? What is sigma? Can you tell me? What is this? What is the definition of sigma? No, you have to tell me the definition. Otherwise, if you don't know the definition, then certainly you can't solve the question number 9. Hello?
Yes, sir.
Yeah, so what is the definition of?
So now I'm not able to recall it, sir.
Yeah, then okay, so yeah, you try to recall it and probably you can ask in the next session. Yeah. So first try to understand what is sigma x. So then probably you can answer this question. Then there is nothing. So yeah, so it's more or less. It's basically the way we have defined sigma is in some sense. Let me give you as a hint. Is completely depend on this A. Okay. So that's why in some sense. So I'm just saying that some sense that cardinality of, if you go back and check. So some sense the cardinality of sigma f is basically the same as the cardinality of A. Okay. That is what,
Okay, sir.
yeah, that is what this question is all about, I guess.
And sir, it would be the, I mean, the cardinality would be less or equal to the cross product, right?
Yeah, because see what just now I said that cardinality of, yeah, that option is correct. So since the cardinality of sigma f is same as
Yeah,
cardinality of,
yeah, it does totally depend on A. Yeah, I totally get it.
and since the cardinality of A cross A is basically some sense less than the cardinality of A times B, so yeah, is so
Sir, is it sigma or gamma?
yeah, sorry, gamma, correct. This is not sigma. Sigma is basically you have some is. Okay, so yeah, probably I'll stop the session. Okay.
Thank you, sir.
Yeah, thanks.
Thank you, sir.
Yes, thanks.
Thank you, sir.
Thank you,
Thank you.
sir.